So just speaking a little bit to today's desired outcomes, what we want y'all to be able to walk away from this workshop today, being able to do. The first one, we'd like you to know how to quantify the solar PV potential on your rooftops, parking, and land based on the available area that's there. The second thing, we'd like you to be able to refine those system sizes based on regulations like net metering and meter aggregation, as well as what the specific site loads are at those locations. And then lastly, we'd like everyone to be able to prioritize a couple of sites so that for next month's workshop, you'll know which sites you'd like to do an economic analysis for based on those on-site motivations. All right, so and also just to kind of take a step back and let everyone know where this workshop stands in this process. This will look a little bit familiar to those on the call last month. But what we're doing today is really focusing on the second part, screening and prioritizing sites. So again, the importance of this workshop today is to, one, have an understanding of what your on-site solar potential is across your portfolio of municipal buildings. And then second, prioritize a couple sites that you can have on hand to do the economic assessment and eventually issue an RFP for later in the process. But now I'd like to jump into our first main session today. I'll be going over how to screen sites using a couple different tools and then quantify the solar potential based on the available area at those sites. And diving into kind of the four primary steps, I'll be focusing on this first one in the first session here. As I said, sizing to the available area. And then Roby will take us through how to refine that system size based on regulations, as well as each site's electricity usage, and then do a secondary screen with more details such as roof issues, future site plans, and special issues like that. And then hopefully walk away with a couple of prioritized sites for your project based on those motivations. So as I said, I'll be focusing on this first section today, and when I'm diving in through these tools, just a couple of things to keep in mind, that the three main topics to kind of keep in the back of your mind are: one, what can the system size be given the available area? And then two, what is the available area based on shading due to trees or rooftop objects? And are there any sites that you should just strike completely given that there's a lot of shading, or they're oriented in a poor direction, not facing south or horizontal to maximize the solar output? So I'll be speaking a lot more to these things, but just kind of teeing up those three topics right now. What I'll be doing is now using Sedona. Mackenzie was nice enough to send over some of her sites, and I'll be demoing a couple desktop tools that you guys can all use to do this initial screening. The first one is a tool that someone on our team, Amanda on the RMI side, created this summer to help cities organize their sites when they're doing solar site selections. The tool is called MIST, and it basically is, the purpose of the tool is really to identify municipal sites that are suitable for solar, screen them, and just organize it all in one nice and organized way. And there's a lot that's in the tool. We won't have time to cover all of it today, but I'll be focusing on this yellow outline section, which is screening those sites based on the available area and organizing that into a list after they've been screened for a couple of things, and then within that tool, using Google's Project Sunroof to figure out what type of shading or orientation that those have, and then NREL's PVWatts to actually draw the area that you want at your site. So what I'll do now is actually jump out of this presentation and jump into this municipal solar site selection tool that Amanda on our team helped create this summer. Again, as I said, the purpose is right there. There's a lot of background that you guys can read about this tool, but I think just given the time constraints, I'll just kind of jump in and show you how you would use it. So the first thing is entering in these blue boxes here is first, is there a minimum allowable project size? So a lot of times people just don't want to do commercial systems that are below, say, 25 or 50 kilowatts, or do a ground mounted system that's below, say, 200 kilowatts. But those are just default placeholders. So those can be changed. For example, we can change those a little bit smaller, since some of the sites in Sedona have a little bit less load than a typical city. And then the second thing that you'll look at is the power density. So that's watts per square foot, and those are some defaults just given kind of rules of thumb. You can also change those, typically seen anywhere from 10 to 18 watts per square foot. 14 watts per square foot is the default in PVWatts, so we'll keep that today. And then for ground mounted systems, it's a bit less, just given the amount of spacing that has to be between those panels so that they don't shade each other. But that could be adjusted as well. The second thing that we'll do is just enter in all of your sites. So Mackenzie sent these over with just their name and address, and whether they were looking at rooftop, parking, or ground mounted systems. We won't have time to go through ground mounted systems today, but it's a pretty similar process. So if you wanted, you could select land as well. But once you've organized all your systems into that list and selected what type of system you're looking for, then it's the second thing that you have to do is enter what the usable space for solar is. And that's where these other tools will come in handy. So I'll go ahead and take the first address here and get over to PVWatts and enter the address in this top left corner here. Click go, and then PVWatts will find that location in Sedona. So then the second thing we'll do is on the right here, click go to system info. And this is what we're really trying to get to, which is draw your system, because you can customize where on your roof you want your systems. So what this does is zooms in on this specific site. So as Mackenzie pointed out to me, it's this rooftop right here, and then this rooftop to the left, kind of bordering this parking lot here. But before we know where to draw the area on this roof, we can actually use Project Sunroof to tell us what the shading looks like at those areas. So enter the same location, and Project Sunroof gives us a nice spectrum of how much solar potential is on all of these roofs. For example, over here, the southern part of this roof receives a lot more solar on an annual basis than the north part of the roof. But again, looking at these two main roofs for this location, it's the one where this red dot is, and then this warehouse building over here. So we can see there's a little bit of shading on the south part of the roof from this tree, and then in the north western part of the roof as well. So keeping that in mind, we could go back to PVWatts and then actually click where we want to draw the area. So actually just clicking, you can draw where you would like to place your solar panels. And we're keeping this southern part kind of out, and then keeping that kind of northwestern part out as well. Another thing to keep in mind is keeping some space between where you're drawing and the edge of the roof, because just given regulations, you can't cover an entire roof with solar panels. There has to be some space typically for people to walk around as well. And you can drag these as well after you've done that. And then the area pops up over here. So this says 177 square meters. We can change that as needed. So kind of keeping that in mind, then we can jump over to this other roof, which looking back on Project Sunroof is pretty much shade free, except for maybe a little bit on the left there. So again, just kind of clicking around and creating what area on the roof we would like to have for solar. So if we want to maybe take it a little bit off for some of the shading on the left part of the roof, we could do that. And then adding those up, that's about 700 square meters, adding those two numbers together. And that is what we would add in this tool. And that, given the power density input we indicated, it'll calculate what the estimated system size would be from that area of that roof. And then given our input assumption on minimum project size, this will tell us whether that's greater than that minimum project size. So I'll do one more example just with a parking lot as well at a different location. It's a little bit repetitive, but I think it might be nice to see a different location as well. So what we'll do is change that location up here, and again, just click go. Again, click go to system info, and again, we're getting to this draw your system customizable part. And this is the building that we're looking at over here. And it's pretty difficult on PVWatts to see what the shading is like. And that's again where Project Sunroof will really come in handy and tell us what the shading looks like on this specific roof. And as you can see, the northern part of this main section receives a little bit less solar, as well as these kind of triangle sections of the roof where there's some rooftop units that are shading the roof, as well as just areas that you can't put solar panels on. So we'll go back to PVWatts again and just kind of trace around the edge, leaving a little bit of room, trace around the edge of those locations where we saw the greatest solar potential. I'm doing this relatively quickly, but also this is recorded, so if I'm going too fast, you can always go back and look at the recording. But from going back to Project Sunroof, it was kind of this southern part of the roof, as well as these sections on the southern part of the building. And that's what I drew over here for where those solar panels might go. And that comes out to, around 180 square meters. Again, this whole process is a pretty high level estimate, just to give you a sense of what your potential could be at those sites. So don't get too worried about being precise, because the contractor will obviously do a more detailed assessment. But keeping that 180 square meters in mind, the second part of the roof that received a lot of solar was this shade-free section. So I'll quickly try to draw that for us. And that comes out to around 100 square meters. So together being 280, we could again enter that in here, see how many kilowatts that would correspond to. And then the second thing we'll do is take a look at the parking lot, which unfortunately, Project Sunroof isn't going to tell you the shading of that parking lot. So you'll kind of have to just infer, given what's around it, which in this case, it doesn't seem like there's too many tall buildings or trees that would directly block it. But again, you can do that yourself by just clicking around. And there's a couple different ways that parking canopies are typically done. One is to just cover the whole parking lot, and then another is to have rows of parking canopies on the parking spaces. So there's a couple different ways to do that, but in this example, we're just going to kind of assume that there would be a parking canopy here covering this main area, and that comes out to around 650 square meters. So we'd just go back here, enter that in, and see an estimated project size for that. I won't go through all of these other addresses right now, just given that it's a little bit repetitive, but I did go ahead and do that on my own, just to give you guys a sense of some of the other locations. This one was a maintenance roof, which was had a rooftop unit that we wanted to kind of avoid over here, but pretty shade-free. And then a little bit more complicated one was City Hall and the buildings surrounding it. There were a lot of rooftop units, a lot of shaded parts of the roof. So I tried to really just focus on the areas that had the most yellow, light yellow areas, with this indicating the most solar potential. And then there was also a parking system that Mackenzie was interested in right next door. So I went ahead and drew that, as well as this office building that the city owns that's next to the City Hall buildings. That one ended up being 15 kilowatts, so that was below our 20 kilowatt minimum, so that's why that one is struck there. And then lastly, there was a recycling center that had a roof that we took a look at that came out to around 23 kilowatts. So yeah, that's a kind of a very quick overview of using PVWatts and Project Sunroof to draw different areas. From the available areas that were indicated there, I'm just quickly gonna go back into this tool here and just enter that in so we can continue along in this example. So as you can see, that office building was just below the minimum project size. But What this tool helps you do is, now that this is organized in one area, we can click that link there, and that'll take us to this page, which gives specific directions on what I just walked us through, which is one, determine the available area of roof space. So for each of these sites that we were looking at, we're gonna have to answer a couple of yes/no questions on whether we did that. So does it have enough available area? Yes. And we could do this for each of the sites using Project Sunroof and PVWatts, indicating, if there's shading, or if it's oriented the right direction, and then eventually it'll tell us how many red flags come up. So if there wasn't enough available area, we'd select no, and then that would just kind of let us know. And it's just kind of a way to organize each of these systems to tell you whether or not they pass, which in this case, I'm just going to go ahead and pass all of the ones that were above 20 kilowatts for us. The same thing is organized for land. So again, I didn't have time to do a ground mounted system today, but this tool organizes in one area, in one tab, directions on how to calculate the available area for a ground mounted system, the grading that's required, some helpful links to figure out the slope and orientation, and then specific things to land like zoning restrictions. There's a couple of helpful links and information, as well as interconnection, which is a little bit more complex with ground mounted systems, depending on how close it is to the system, to the site. But after that, we'll just get to this one organized list of our pre-screened sites with the parking systems up here and their kilowatt system size, as well as the rooftop systems organized below. I won't have time to cover these green tabs over here, but this is the green tabs cover the secondary screening that Roby's going to cover in the second session today, which is just a lot more detailed information that you'll have to do, which is a little bit more time intensive, like figuring out zoning restrictions, specific site conditions like the roof's age and pitch, as well as ability to support load, and then any additional resilience or permitting and regulation issues. And those tabs are organized for rooftops, canopies, open fields, contaminated sites, landfills, etc. So then there'll be a list of final sites if we were to enter in all of those accordingly. But for this purpose today, I'm just going to focus on these pre-screened sites and the kilowatts there that are associated with it. So now just going back to our presentation here, we can see that we have the kilowatts associated with each of these sites, but we're also going to want to know the annual area that's associated with those kilowatts. And we can use PVWatts to do that for us. And it's important to get the annual energy, because Roby will taking us through the next section on comparing that annual energy to the site's load, and then resizing those solar systems to those site loads if need be. So quickly, the last thing I'll do before we can have a discussion is return to PVWatts, and we'll actually enter in system sizes into this DC system size category. There's a lot of defaults in here that you can change depending on if you think it'll be tilted, what degree that'll be, if it's directly facing south or not. For now, I'm just going to keep all the defaults for simplicity, but those are things you can look into modifying depending on the latitude that your site is at. So once the results in PVWatts will tell you the annual energy that's associated with that, as well as the monthly totals associated with that. You can even download hourly data if you need to do a more detailed assessment. But for at least at the high level, for purposes today, we just want to know this annual energy. So that's what I did and entered in accordingly for all of our sites here. And that is a very quick summary of what you would do at a high level to calculate potential solar at the available size to the available area. And as I indicated before, Roby will take us through kind of that resizing exercise next.
All right, well, thanks everyone, and thanks Ryan for that detailed look at using two pretty cool tools, Google Sunroof and PVWatts. Weren't available way back when I started doing solar assessments manually decades ago. So great tools to help save time and help you prioritize. We'll take it a few steps further at other things we can look at. So he was focused more on the availability of the size of the system and roof systems, ground mounts, so forth. Now we're going to take a look at how rules and regulations and your electricity usage might impact how you refine your size of system. So just taking a look here, we're going to look at each of these in detail: meter aggregation, net metering, and interconnection policies. This site here is really very useful. I think many of you have visited the Desire website before. This is an NREL site that has some of the same components, and it gets you to specific state policies pretty quickly. So you just scroll down through this page, and then down below it has state policy inventory. We're looking at Arizona today, so we just come over and click on Arizona, and it has all of the information that's publicly available on Arizona in regards to, renewable portfolio standards, carve-outs for solar, utility systems, etc. We scroll down and we see they have policies explained for net metering, for interconnection, and all of that. So a great resource to go to find out what's going on in your state if you don't already have that information in front of you. And what we're looking at particularly here is meter aggregation. We'll describe it a little bit more as we go, but it basically says not addressed, which means, you are, oops, sorry, get out of the wrong window here, Ryan. If you don't have meter aggregation, then you're going to have to proceed looking at individual sites. If you do have meter aggregation, however, it allows you to take electricity from one system and apply it to other buildings that maybe can't have any solar on it. There's no available room. It's a great feature to have, and it enables you to take your sites that are easiest to build, larger sites, etc., and apply the energy they can generate towards your other buildings in your larger portfolio. So it would make you look towards the max of every system that you have. So as we look here, we did this sizing for each of the systems. Here it's listed in kilowatt hours, and then this is the estimate of how much energy they would make annually. So 750,000 kilowatt hours, and we can see the annual load is just about 1 million kilowatt hours, but we would, in this instance with meter aggregation, want to install all the systems we can. If the cost of the systems, what subsequent screens would come, but if the cost of the system is okay, we would apply it to as much of the city load as we can. If you don't have meter aggregation, then you take a different look at this individual site loads and say, okay, I want to start limiting how big my system is, so I'm focused on the site loads. So we can see here for the Sedona maintenance building, the load is 37,000 kilowatt hours. Even though we could generate 170, we're going to target the system to match that load. Here we look at the Park Center, and there was, the parking lot doesn't really have a load, it's just the building itself, so we can size this system just on the roof to meet the building load, and so forth with each of these. Here again, we have a parking lot, and we can combine all the availability on top of the roof, plus some from the parking lot to meet the full building load. Okay. We have other policies that impact what we do, net metering. And I have some graphical slides that will follow where I'll dive a little bit deeper into these, but net metering allows you to receive credit for solar energy that you send back onto the grid. If you make more in a particular month than you use, okay? Most of the time, we're in the Northern Hemisphere, our systems will make more in the summer months. of course, for many of us, our loads might be higher in the summer month because of air conditioning. So it kind of depends. And again, at some stage, you look at individual modeling for it. But that net metering is a nice feature. There are different rules for it. Sometimes you have to true up monthly. So on a given day, you make more energy than you use. Later that month, the sun's not out because of clouds. You can go and get that same energy back from the utility at the same rate that they bought it from you at. So that's nice. In essence, you're using the utility as your battery. And if you do that, well, the utilities sort of need some compensation for it. They'll go out of business being a free battery for everybody. So if they do allow net metering, you want to make sure you understand all the other implications. It may be that they require that they have REC ownership instead of you, if they're allowing you to take advantage of that. Even though you might be on a sunny day making all of your electricity and operating totally off of solar, if a cloud suddenly goes by and you have to rely on the grid is always there ready to back you up. You're on standby basis. They might have, standby fees to enable you to be running your solar system. So you want to make sure you understand what those rules are and how they impact things. But generally speaking, you might be looking at meeting 80 to 100% of your load. A couple things for individual buildings. A couple things to bear in mind. If you have an aggressive energy efficiency program and you expect your loads to go down 5 or 10% a year for the next few years, well, then maybe you don't want to oversize that system by too much. On the other hand, if you're going to be transitioning your thermal loads into electrical loads, so your electricity load will increase over the next few years, or you're going to have your electric vehicles being charged at some of those building facilities, again, increasing your electricity load, then sizing closer to that 100% might make more sense. The utility will have rules as to how much you can oversize a system, generally speaking, so those will guide you. If you don't have net metering, then a general rule of thumb, and you might be shocked at how low this is, but you might size your PV system closer to 15 to 35% of your annual load. Part of the reasoning is most of our buildings aren't open on the weekends. There's no load there, but the sun's producing electricity you can't really use. Same with the holidays, and even the sun can be up generating some electricity between 6 and 8 a.m. or 6 and 8 p.m. when your city offices aren't necessarily open. These are the type of things where you want to actually go and use some sort of modeling software, Solar Advisor, System Advisor Model, SAM, or re-opted NREL. We'll take a look at that at webinar 3, but just something to be aware of. Another aspect that might limit your system size is interconnection. Generally speaking, every utility will say, for a commercial and municipal load like you, there will be system size limits behind the meter. It might be 10 kilowatts, it might be 50 kilowatts, it might be 500, but they will have some restrictions. For residential also, they have different restrictions, but often much smaller. The size wiring going into your residential systems is much smaller than for commercial buildings. And then
I would just add just really quickly in the example below in Sedona, since there was not meter aggregation, we first resized those systems to 100% of the load. But since they do have net metering, then those system size limits now are about 90% of the load for the maximum. Some of those are obviously just lower than the last one, the recycling center is just significantly lower than the annual load. But now the maximum system sizes are, in this example, are about 90% of the load, and they're all below the interconnection limit in APS's territory in Arizona. So that's just the case study example below.
Yeah.
Yep.
Thanks. Now we'll just take a look at how some of these rules parlay and might impact your thinking. So this is a graph of states that have meter aggregation policies. They do vary state by state. Some, you're limited to how far away the building load you're trying to serve can be from the PV system. In Pennsylvania, I believe it's 2 miles. Most of the other states, I think it's 1 mile. So, you can serve your broader city loads, but you can't do it from, west side of town to east side of town, generally speaking. They'll discuss which technology types and system sizes are allowed. Generally speaking, solar is allowed. There will be limits on size. Some of them allow wind systems, some of them allow biomass systems, that sort of thing. It depends on your particular state. And then customer type. So they might not allow meter aggregation for residential systems, but for municipal or certain kinds of commercial, they will. Another map that shows an important feature of the meter aggregation, and it's from the utility perspective. This is saying, again, you know, the utilities can't provide free battery service and everything to everybody. They're trying to make money selling electricity. So there are going to be different limits to how much of their generation they have to allow to fit under an aggregation cap. As we look at a couple of these states, you know, here's Virginia, 1% of the utility load can fit under this aggregation. We look at Alaska, and it's 1.5%. Okay, we look at some other states, and it's much higher. For instance, Vermont is at 15%, Massachusetts 9%. We look at Georgia, 0.2%. So the point of it is, find out what your utility cap is and understand, are they close to it or not? Once they reach that cap, even though there's quote unquote net metering available, or excuse me, aggregation available, they don't necessarily have to allow it for you. I'm sorry, I was saying aggregation when I meant net metering for this entire slide, okay? But it speaks to they don't have to let everybody use net metering. They have limits because, again, they're in the business of selling electricity. Letting everybody use them as a free battery would put them out of business. So understanding if your utility is close to that net metering cap, you can, quote unquote, have it available in your state or your utility district, but your system might not qualify because the cap is already full and fully subscribed. My apologies on that. Just in case you haven't looked into net metering or anything in the future, interconnection, the utility has to allow you to interconnect your system. You do have to go through a system impact study, apply for this. Generally speaking, these systems are very small, so it's a pretty routine application, and they have to let you on. The question is how much they pay you for your excess electricity generated. There's two options. One, with net metering, they give you the retail rate. Without net metering, they give you the avoided cost to generate. So we'll take a look at two examples of that. Okay, with net metering, let's say you're paying 9 cents a kilowatt hour. You have excess generation in August, so they give you a credit for that 9 cents, for those kilowatt hours that you put onto the grid. And then come November, you need to buy them back. You buy them back at 9 cents, so you take it from your credit. It's exactly the same rate. So if they're doing this if they're doing a true up on an annual basis, then you can look at, hey, I want to make sure that my system will deliver as close to that annual load as possible so that I can get to use the full benefit of net metering. If you don't have net metering, again, it's the same situation where you're generating some excess electricity. Now the utility will pay you or give you credit for 3 cents a kilowatt hour. That's how much it costs them when they're generating. And yet when you go to use that same electricity later, you're going to pay the full 9 cents. You're losing 6 cents a kilowatt hour for the electricity you generated. Okay, that's a losing economic proposition. And so we don't want you to get into that situation, generally speaking. And that's why this rule of thumb of 15 to 35% is so low. You want to avoid giving away your electricity to the utility. It will hurt your overall economics a lot. You're generally sizing systems to get the full retail value. You know, that's what you're not having to pay to the utility, and that's what makes your systems work economically. So those are some of the rules and regulations that apply and how you refine things based on your electricity usage at each site or an aggregation. Now we'll take a look at some other information that will help you further screen. Okay, this pertains to the building. We talked in our first webinar about your on-site solar procurement team and having a buildings manager, a buildings engineer, maybe someone with environmental on your team. And this is when you want to use them to find out more information about these buildings. It's not expected you would know all this information. What are the future site plans? Is this going to be building raised and build a new one? Are we going to sell this building and build a new one somewhere else in town because the town has grown up around things and it's now more convenient to have it elsewhere? Roof age, is it your PV system you can expect to last at least 20 years, 25 or 30 is not unreasonable. And so, taking a look at a roof that's already 10, 20, or 30 years old, might be a limiting factor. It makes a difference on several different aspects of your roof, how it might impact your system. If you have a flat roof, you can have PV systems that lay flat on that roof and it doesn't require much ballasting. However, you're going to take a hit in terms of energy production because flat, horizontal is not the best angle. If you tilt it up, now you create a bunch of wind sails on your roof, so you're probably going to need some ballasting to hold it in place. And that, more than the weight of the PV, might be the thing that makes a rooftop system not viable on an older building that was built without that loading in mind. Again, you'll need a civil engineer familiar with your buildings and the building plans, the structural design as it was built, the as-built drawings, to do some calculations to determine that. Anyone in the northern half of our country, of course, you'd have snow loading built into any of those calculations, but you'd also want to have the wind loading and the dead weight loading that the ballast system might provide. You have historical buildings. That often is something that can be a bit of a flag, but do recognize we can work around them. For instance, Department of Interior building, Smithsonian building on the Mall in Washington, D.C. Wonderful skylights above meeting rooms and the historic structures. Well, they wanted to update them, upgrade them, and put in PV glazing. So they were able to do that, even though it's a historical building. Beautiful office, beautiful meeting space, great light shining through, generating electricity as they go. Of course, an expensive fix, so often it's going to cost a little bit more if you do have to do that. Also engage with your state environmental policy people. Typically, systems on roofs don't have a lot of broader environmental impact. It's more the ground mount systems. We heard Yale talk about prairie dogs and making sure your systems are safe for the prairie dogs to be able to continue to colonize, all that kind of thing. But you have people already in your city team with expertise in each of these areas. You need to bring them in to get more information as it will help you screen out the sites that are going to be too costly to try to continue. At the end of the day, we're always looking at the most cost-effective sites, the low-hanging fruit, so that's what we want to keep in mind. We also can get more information about the energy at each of these sites. Again, looking at our core team, maybe you as the energy manager, or if someone else is the energy manager, utility liaison, or an energy services consultant, you want to start looking at the individual building loads, if there are different rate structures that apply because it's a different type of building. If you're going to be requesting real electricity data, try to get the hourly data for modeling purposes. That's much more useful than just monthly. If you can get 15-minute interval data, that's even better when you start doing some of the subsequent modeling. We didn't do any of that today, but we will in webinar 3. That data will take some time to get, so asking for it early and giving them time to work through and send it to you would be useful. Sometimes it's on an online account. You can access it yourself. So I know different clients I've worked with in the past have given me access to their account, and you can get all the information you need. But you have to ask early, get the permissions, or get the data to help you follow through on that. Okay? And there's different tools, again, free online tools that can help doing more detailed system performance and economic modeling that we'll do in our next webinar. So now we've taken a look at system sizing, refining the size based on rules and regulations, electricity usage, screening a little bit based on other issues having to do with your buildings, and the age of roofs and so forth, future site plans. Now we're going to look at prioritizing. There's a lot of different ways to prioritize, but just pointing to some of the things we talked about from webinar 1, here's just some broad rules of thumb to maybe get you a little focused. If one of your motivations for doing a system on site is local economy, the larger projects will have more impact that way. So focus that way. If making the economics work, that it has to demonstrate savings to the city, again, larger systems generally will help that. The other thing to look at is it really depends on what your energy rates are with the utility, what you're paying, or if you have high demand rates, it could be that you can use these systems to help offset that. And another factor could be it's an easy install. Just because it's at one particular roof, it can support the load, everything else, it can be real easy to install. Another roof, it's sloped, it's got lots of protrusions or things like that, and it might be a nice site. Other than that, great solar access, but the actual installation will be too costly. So there are different aspects of that can point you in the right direction. Climate impact, the larger sites will give you the biggest bang for the buck. Same with health impact. Do remember, generally speaking, you're not going to see any health benefits, in your local community. It's going to be more on a broad-based area. If, however, you're using your PV system to be able to shut down a city-owned coal-fired generator, well, then you can see local benefits right there in the emissions. But, most of us don't have that type of situation. Resilience is something that a lot of people consider to be important. And so as you're determining where systems will go, take a look at critical city functions and loads. It might be City Hall being able to call the shots of how to respond to an emergency situation or a natural disaster. Likewise, fire stations, police stations, city hospitals, if they're in your load, emergency shelters, etc. So those are all things to consider. And then, lastly, and this is only lastly from our list, there are many other factors that might be in your list of priorities, but the visibility within the community or the educational opportunities. Visibility are where people go most of the time, a recreation center, community center, or library. Educational might be more focused on your schools or, a city hall building that, everyone's always downtown. So it depends on your priorities. I'm a former math teacher. I know what happens to people when they look at a table full of numbers. Eyes glaze over and everything you say after that doesn't make any sense. So I like to do color-coded things to help orient my own thinking, but even the people I'm working with. So here we see the different criteria that we've just talked about. The one I've added in is system size contributing to a 200 kilowatt city goal. You can put in whatever you want here. Up at the top, we can see the weighted values with each of these. So I consider, contributing to the goal important, the energy economics, making it viable, very important, the health impacts, climate impacts, not so much. It just helps do the scoring to be able to represent what your final prioritized sites look like. I've done a simple scoring system here. 1 is the minimum, yellow, green is the good stuff, the best, 5 is max. And just looking at one particular building, the Sedona maintenance building, we can see it's a small system, only 20 kilowatts. It doesn't contribute a lot to the goals, but it has decent economics, not much of a health impact. It does help with city resilience. Again, these are all just my estimates, but you have your own. We can then go and take it further for all of the different sites. This screening gives us a good visual of our own scoring metric. Is it fair? Do all these sites come out the way we expect? So going vertically, you can compare the sites to each other. Going horizontally, you can compare what the different city factors are or motivations are to see how they work. We know we could just look at the right and the tally. Hey, 695 is the highest, 590, that's next. So, that tells you what you need factually with the numbers. The color coding just helps you get a little bit more oriented. It's a suggestion. You can do whatever you want with it. I'll send you this tool, but it's a way to help explain complex tables of numbers to people whose eyes glaze over when they see them. And then if you've never used this shading feature in Excel, it's kind of neat. It's from the home screen, you go to conditional formatting, come down to color scales, and here you have a wide variety, but I just chose, the green and yellow.